Sorry about that. I'm fetching my stuff. Okay. Okay, so we have done that last time. So I'm just going to refresh your memory for a few minutes. So the Malthus model is describes what happens to growth and population growth before the Industrial Revolution, and so what we've seen is that there's struggle for life, and a good piece of evidence was this piece of evidence that showed that if land is more productive, it doesn't really mean that people are richer or more wealthy or happier, but it means that they have more children and they can sustain a more dense population. But this denser population means that all the gain that they had from land productivity is lost, and they are basically as not rich as the people who have the least productive land. And so this was our discussion about how are we going to be able to sustain ever increasing population. And so yeah, this was our Malthus model based on the dynamic of B4. And then yeah, we've seen that and that. Okay, and here we are. Okay, let me take that out because that's that's some part of the answer. Okay, so here we are. If so, yeah, in like two years ago, so what was presented was a unified model in which we had both endogenous population growth and endogenous technological growth. So it's like a Uber solo swan model with Malthus model in between. So it's interesting to think about this, but I didn't think I wanted to continue because the two worlds are so different that at some point to have some unified model, you have to have some unified motivation of agents within your model. Agents must want something that is always the same. So you have to assume that the reasons to have children in the past exist in the same way as they would exist now, but now some other thing exists in today's society that makes people not want to have as many children as before. So it's possible to do it. Thing is, the society is so different that so I prefer to just show what's happening since Malthus's world. So since population has escaped the Malthusian trap, just to give you some information about where things are going mostly from a demographic point of view, and then yeah, and then move on to other topics. So here is a graph of the world population. So on the horizontal axis is the year, So this is today, and this is Jesus Christ. And here is millions of population. And so I'm not going to say anything, but look at the scale here. And now let me ask one question. So is this an exponential growth or not? And if not, then it means that you have in mind what you should observe if this were an exponential growth. So this is just to see if you learn something during your problem set or not. So feel free to answer in the chat or.
Until the 15th century, the growth is not exponential, even though we have a logarithmic scale.
In the 15th century, so you mean?
I mean, up until the 15th century,
Okay, up until
it's not
here.
exponential.
Yeah, and
And
here
then it is.
it is. All right. Okay, some other opinion? Maybe it's right. I'm just gathering opinions from different people.
Maybe it's a logistical growth. Like it starts like in a linear way, becomes exponential, then it stays, it becomes linear again.
Okay,
I
what you
think
have in
that's
mind, yeah, what you have in mind is like what's happening later on, right? The fact that
yeah.
maybe it's going to flatten here. So good answer, but so if we just look at this graph, but yeah, if I had to compare the two, I would say maybe logistic is more precise than exponential. Or maybe let me ask the second question then. How do you recognize an exponential growth?
It looks like a line on a logarithmic scale, maybe.
Yes, good. And does that look like a line?
No.
Well, yes, it looks like a line. It's just a curved line. Yesterday you said the same thing. It looks like a line. Yeah, a line for me is this is a line. So of course, yeah, it's a straight line. Why? Well, because exponential just means that it grows at the same rate at every period. So imagine that, yeah, try to write something. So if you have population, oops, population at time t, yeah, time t, it's equal to population at time 0 multiplied by, so let me multiply it by 1 plus some growth rate, exponential t. So that's what we mean by exponential. It means that the t is here, it's not multiplying p, for instance. So it means that at every period, I gain some fraction of new people. And since this is a logarithmic graph, a logarithmic scale, then I know that, for instance, here, so I double from 200 to 400 million, then I double from 400 to 800. So if I always increase by the same rate, then it means that basically I should take the same amount of time to double. So in fact, it looks like here it's exactly exponential. Is that the case? Well, no. The thing is, well, it may be, but the thing is, it's very hard to have precise data for that period of time. So I had like one data point here and one here, so that's why this is just the best guess of what happened in between, but I don't know. And we have some idea of pre-Christian population and the whole planet, but it's just so vague that I didn't want to risk showing it and give you some false idea. But yeah, it looks like, yeah, and here it looks like it's slowing down a bit, but here it doesn't look exponential at all. It looks more than exponential. The rate of increase is increasing. So you can see that, say, from 0 to year 1000, then we roughly double the world population. Then if we consider from 1000 to 1750 maybe, so it took a bit less time to double again, and then it was multiplied by 2 by 2 by 2, so by 8 in like 250 years. So that's a crazy increase in the population for a short period of time. So I don't blame people back then to think, oh, we're all doomed, we're all going to die because we're all going to step on each other's foot, because they were witnessing how much how many new people were there was, and especially past the demographic transition in the populated world, and they were looking, oh, people still have many children, but now the death rate for young children is not as high as before, so it means that we're going to be 20 or 50 billion in the future. But that didn't happen. Why? Because, as was rightly said, it looks like the world population is not an exponential curve. It looks exponential, but let's say for that period, but then it stabilizes. Oops. Yeah, so this was, dear, sorry. Okay, so this is a population then. So here we start at 1700, and here we are now, and this is the future. And demographers believe that exactly it looks like an S, so it looks like logistic curve. And like we observe in the logistic curve, it looked like it, but actually it's not like it's a logistic function necessarily, but yeah, it looks like an S. And the interesting thing now is that, of course, this is projection. We know that the peak growth was in 1969 at 2.1%, but then this is what demographers think, and but it's a projection, and it's not clear that this is where we're going. This is from UN data. But some other demographers think that actually we might not even reach 11 billion in 2100. Some demographers think that we may reach 9 billion, maybe even 8 billion, and that actually the peak population would not be here, but it would be mid-century. So that seems very surprising, but you could imagine that after like not so long ago, having some crazy population growth, the world population could reach its maximum like in 2070. So something like in 50 years. 50 years, the global human population could reach its maximum and then starts to go down. So thinking about how things never change in the past, because things were always the same, growing very slowly and looking always the same, then it's within 100 years, it's a huge change. Yeah, and so this is the range of estimates that we have. So this is the UN estimate, I think in purple. Yeah, or yeah, UN in purple. So it's a mid-range estimate. And then what matters for this? What really matters is actually one thing. If you can coin one word that we should have in mind, is urbanization in countries that are growing fast in Africa. So that this is the key. If they don't urbanize very fast, then their population could grow very fast and reach heights of 11 billion or more. But if they do urbanize very quickly, then their population growth rate could slow down like it did in Western countries. Yeah. So just as a side note, so we have seen. So we just saw two chapters, one on the potential climate crisis, and one on, well, this chapter on the fact that people think that we might run out of food. So we may do our best to limit somehow emissions with some technology or with limiting growth somehow. But it's not going to maybe make lots of impact. We're very good at producing food efficiently, and we are always progressing. But still, if we are to keep climate kind of under control and to survive as a species with enough food, there is one huge factor, and that's this factor there. It's how many people do we have on the planet. Whatever the impact, environmental impact of people, if we are 1 million, it doesn't matter. But if we are 10 billion, then that starts to matter. So that's really the lesson here is, and this is it's something again that people couldn't have anticipated before. So why do we think that demography is key, or rather that the demographic transition is key? Well, because we know that this is the reason why Western countries have started to have fewer children. And now, just to probe your preconceived ideas about the demographic transition, because mine were changed when I prepared this. So just can somebody guess what percentage of the whole world has gone through demographic transition? By demographic transition, I mean a regime with high birth rates and high death rates to a regime of low birth rates and low death rates. So of course we know that the Western world has gone through it, and now where are we, more or less? No idea? No guess? Think about the big countries in the world, where they are.
How can we guess this?
Can you repeat your question?
How can we guess this?
Well, I'm just probing your understanding. So okay. So let's go with, so when we ask in science, social science, when we ask surveys to people and they have no idea, what we typically say is, okay, is it 50% more or less? And then if they say more, or do you think it's 75% more or less, or 25% more or less? So where is the world in terms of demographic transition?
1/3.
1/3. So you basically what you have in mind is roughly 1/3 of the population has gone through a demographic transition, and 2/3 is still ongoing, right?
Yes.
All right. So I just wanted to have one answer, because my preconceived idea was more or less that too. But thing is, as we've seen, so in the beginning of the class on growth, things have changed a lot in the last 50 years and the last even 30 years. And the countries that we used to think that are not that advanced or rich have become much more developed. And as with other developed countries, they have become much more advanced in terms of demographic transition. So here it is. So this is so fertility. So of course, high fertility means you're not, you haven't gone through a demographic transition, and low fertility means you have gone through it. And this is in the world. In 2015, you needed a fertility of 2.3 to be at population replacement level. Why? Because it reflects, on average, how many women die before they have completed their age where they can have children. So if, of course, if they never died before having all their children, then we would just need two children per woman. So 2.3 is a bit higher. And so this is roughly your idea of where we were. So so this is the whole planet. Here are populations with the lowest fertility rates, so that have finished their demographic transition, and here are the highest fertility rates, so populations that are not finished with their transition. And this is roughly this 2/3, 1/3 divide. But this was in the 50s. And then what happened? Well, in China, they had their one-child policy, and fertility went from this, which is how many? 2, 3, 4, 5, 6, more than 6, to 3 to now below 2. So it means that they are below replacement level. And India used to be like China, but then they went down not as fast because they didn't have the same policy. But here they were, this is for the average between 2005 and 2010, but that's not even up to date. So there's a nice article in the Lancet that looks at demography right now. That was founded by the Bill and Melinda Gates Foundation. And now India is at 2.1. So India is here, it's below replacement. So what does that mean? It means that roughly almost 80% of the world has gone through demographic transition already. So this is why we believe that this is right, that population is going to be stagnant in the next century. So population is not, by the way, going to decline right away. Why? Because people don't die as quickly as they did. So this world is a world in which you have way fewer young people, but lots of people with gray hair. So it's a completely different society from the society we see today, or even from societies we used to see, say, 100 years ago. But this is the state of the world right now. So that's extremely surprising for me to see how fast and how fast it occurred. So to change from this world to this world in just 50 years, it's crazy. All right. So and then, is this a world that looks like the Malthus world or not? Well, no. Because in the Malthus world, well, okay, let me ask a question. So what's different here from the Malthus world? So this is, there's a really good answer now. It's not a guess, you have to remember. So I'm just going to say, so here is average income per capita. So it has to do with productivity, with with how much stuff we are able to produce. And here is births per woman. So it has to do, of course, with how many people you're going to have in certain place. So does that reflect or not what we used to see in Malthus?
No, it doesn't.
That's right. Why?
Because now we're seeing that the more the average income increases, the births per woman decreases. So it's the exact opposite as Malthus.
Exactly. You have to go ahead, finish. Oh, you're done?
Yes.
Okay, perfect. So perfect answer. So yes, in Malthus's idea, you're rich, therefore you can, so your only life goal is to make sure that none of your 12 children die. And if you accomplish that, then it's a good life for you. Well, that's not the world right now. It looks like rich countries, they think that, okay, I have more income, and but I want to have fewer children than before. And even if you have a keen eye, you might have realized that these are more than 200 points. So we have not just countries there. So their countries in some instances are split between the income quintiles. So you have the bottom quintile in blue and the richest quintile in purple. And here is when we don't have it, it's country average. And what do we see? Well, we see that, so the blue is over here. So the poorest of the poor countries are the ones who still have many children, so 7, 8, whereas the richest in the countries, they usually here in purple, then they're down there, they have fewer children. All right, so now put on your economic hat and come up with some explanation. So why do we observe that for now? What is the motivation behind that? Can be an economist hat or a demographer hat. I just want good explanations.
Well, often when there is a high average income per country, there is high quality in education, for instance, and for health issue as well. So you don't need to have 12 children to make sure that one will work later and assure you a future revenue, for instance. So one child or two is enough to make sure that he will work later and provide you with some stuff, for example.
Oh, it's perfect. It's insurance, and also it's a perfect segue into the next chapter that we're going to see. So that's actually an economic intuition. So the intuition is, yeah, I'm not sure. I think it was the motivation for the last model with the Unify, but I don't want to go into that. I don't remember exactly. But yes, so thing is, so in Malthus's world, why do people have children? Then one reason is that they can't control it necessarily because they don't have good contraception. But even with quote unquote contraception, there still is social pressure to have children just because you know that if you're just by yourself in old age, then it's not clear that people are going to want to care for you. And maybe it's not that easy to put money aside, and maybe there's risk to that. So at least if you have some kids, then you know your kids are going to help you survive. So are there no other different explanations? Otherwise, I can go with my suggested ones. Oh, everybody had the same answer, I'm sure. Okay, all right. So let's go. So here are some explanation. It's not the only one. So here's a link between, so from GDP per capita to population growth. So of course, if you are richer, then you have mechanically more access to birth control. So people that would like to control birth, then it's easier for them to do. So regardless of values, but of course, the fact is the values have changed as well. So there's also a reduced number of the desired number of children, just as a matter of, instead of having like 10 children to work on your farm and not get good education, then you want, okay, the reason you want a child may change. You want a child that's good, well educated, and is going to have a successful life, and you know that education is expensive, so you trade off quality for quantity. Then another more mechanic cause from the other way around. Here is GDP per capita to population. Here is population to GDP per capita. If you remember, in the solo swan model, then if n goes up, then at equilibrium, GDP per capita goes down. Why? Well, for the simple reason that if you have many new people who arrive on the labor market, then you need to equip them with some equipment. So it means that there's the investment that you put in the economy is a bit lost to not lost, but it's used to equip those people instead of replacing machines that break down or increasing the number of machines per worker. And then we can have some mechanisms that both explain one and the other. So insurance market is one. So If you have good insurance market, then as we just said, it's so you don't necessarily need children to care for you in case you are sick or in case you are old. So you can just put money aside or take a life insurance and you're good. And also having good insurance is something that's good for GDP growth. It's good to have good institutions. And education, same thing. So education is good to have productive workers and have a high GDP per capita. And it's also good to just educate people, and especially educate women on how to manage their lives in general, and to avoid having too many kids if they don't want to. Yeah. So if we want to so these are lots of explanation, but as I've just said earlier, there is one overarching explanation, which is in fact urbanization. Which is an umbrella term for everything else. So here are my two demographers that I just told about previously, Bricker and Ibbotson. So they wrote this nice book in 2019, so Empty Planet, Empty Planet, the shock of global population decline. So it looks like we're heading down to a total catastrophe. Well, that's I'm a bit disappointed by their title for two reasons. So if we go back to their prediction, so does that look empty to you? No, it looks exactly as populated as before, as today, or even a bit more. And also, does it look like a shock to you? A shock to me looks like, and then a shock of population, or a shock of population like this. Here, this is extremely flat. So it's not a shock, and it's not empty. But I guess I get that they have to sell their books. So what's really at stake here is just to wrap our minds around the fact that what's in store for the future is not what's in store, what was in the past. And in the future, we're not going to see the same population growth as in the past. And so so for them, their thesis is that urbanization is the key driver of population. Why? Well, so in cities compared to the countryside, then children are not necessarily help on the farm, but they are another mouth to feed. So there's not that same mindset of having children to help you have a good income if you work, say, at the factory, for instance. So it's not like employees on the farm. In urban cities, women have more access to education, whereas they might be more isolated and less educated in the countryside. They can see more women if, say, their husband, I don't know, they work elsewhere, then maybe during the day they can meet many women in their neighborhood, whereas they would maybe have worked on the farm too if they were on the countryside. Now they can have access to other people and talk about contraception and other things. And then so these women invariably decide to have fewer children than their mother, is because in cities they are exposed to other ways of lives. And the authors, they talk about one specific example that's interesting is telenovelas, or just TV shows on shows on the TV. In many developing world, what they see is telenovelas in which they see some very rich and wealthy family that has crazy life with crazy things going on, like in all things that happen in television. But there is one thing that's always the case, is they don't have a lot of children. So they look modern with future children, and that becomes their aspiration. So that's what they want to aspire to in the future, not that what their mother did. And of course, more contraception methods are available. And a bit about the isolation too is So in the countryside, then the traditional powers such as religion or tribe are in decline in the city. So what this means is, so the value of the tribe or the religion might be, like have many children to populate the earth, or to have to make your tribe powerful. Well, in the city, that's not relevant that much anymore. And then one key thing too is that once the norm of having 1 or 2 children per woman is adopted, it is, as they say, virtually impossible to go back. Even if government programs encourage larger families, they don't have a big impact. And to testify for this, just think about the situation in France. So in the French situation, it's extremely generous for women to encourage them to have many children. And if you have like 3 or 4, you have some extra money that you get from the government. And you can have a very long holiday, and your husband can take a break from work too. And it's yeah, so everything is made to have a good coordination with work life and family life. Compare that with the US. In the US, it's yeah, there's basically nothing for women, or very little. They have like a few weeks to give birth, and then they go back to work, and they don't care about family life. But if you compare demography in France and the US, then the size of families is more or less the same in the US and France. In fact, it used to be a bit higher in the US because they had teenage pregnancy. Now it's a bit gone down, and it looks like it's in France. I'm not saying it's low in France. It's kind of high. It's 2.1 or something. It's close to replacement. But you're try as a French government to encourage French women to have 4 or 5 kids. Good luck. They say, no, I know that having kids is difficult, and I want to maybe do other things with my life than just that. So I want freedom, and yeah, there are other values around. So when this norm is adopted, then it's very hard to climb up. By the way, if you look at, say, China, so China, they had their one-child policy for a while, but now the Communist Party is looking at things and looking at the Chinese population becoming old, actually. And they're thinking, oh, well, it's good that we're growing, but maybe if our population is starting to shrink, then it's no good anymore. So now they abolished their one-child policy, and now they say, yeah, one child good, but 2 child good even more. And yet it's there's little chance that China would go back to 2 or 3. They might go back to a bit more if there's encouragement. But the norm is the norm, and now the norm is not it's never going back to, say, the past. And that's the same for all industrialized countries. So then what is the result of this? The result, so this is the result, the net result. So we have looked at fertility rate, so how many children are born per woman. So this is the net growth of population in each country. So what you have to add to that is net migration flows. And what do we see? Well, we see that so in Africa, there's still net very high population growth. And strangely, in the US and Canada, population grows faster than in France. So why is that? Somebody has an answer? or maybe it's a too easy question to ask. So yes, because I just told you that the fertility rate isn't that all that different between France and North
Immigration.
America. What?
Immigration.
Yes, exactly. People just want to go there. It's very easy to immigrate to Canada, and all these people that are here, they're just moving here, and they're looking at the nice landscape and winter, and they say it's so awesome. So I'm staying in Canada. And very few people do the opposite, like some teacher that I know that come from there and then went here. But no, it's a good life in France too. It's just that, yeah, it's very easy to immigrate to Canada and to immigrate to the United States, and still nowadays, even with all the troubles that they have with the polarization of their political system and weapons, and you can name many flaws that the US has, still that's where people like to go and they migrate. And one notable thing is what's happening to the countryside in China. Well, it used to have a very high fertility rate. Now, not only is fertility starting to look more like Europe, for instance, but people are escaping certain very rough and poor areas of China and moving to the coast because they can make money to the coast. So that's the whole flight from the countryside to the city. And so, by the way, I think it was something like 10 years ago, maybe, that for the first time, the world has more than half of people on the planet lived in cities compared to living in the countryside. One country that's having a very hard time is Japan. So it's in orange. So by the way, everything that's in orange means population is declining, and in green is population is increasing. So yeah, population is in Japan is declining quite fast. So so what they think is what demographers thinks is with the current trends, and yeah, one other thing is it's very difficult to immigrate to Japan, so they don't accept immigrants. They want to stay within themselves, and so they're becoming extremely old. So some demographers think that in year 2100, or maybe before that even, so the population of Japan could have been divided by 2. So that's again a crazy thing to imagine, because in the 60s, 70s, the population was growing extremely fast. And one thing that they say is that nowadays the market for diapers for young children is less big than the market for diapers for adults. So if you didn't get that, what I said is le marché des couches culottes pour enfants est plus petit que le marché des couches culottes pour adultes. So you can let that sink in. Oh, and so one region too that's very sadly losing population is Balkans. So do people know have an idea? I didn't know what was happening there. No student from the Balkan. I haven't watched the list of students. Yeah, maybe we don't have.
It's maybe emigration.
Yeah, exactly.
Because
so,
many of people who are coming from there are going to England and other parts of Europe and the world.
Yeah, when Germany said, okay, we have a migration crisis, so we open our borders, the flow of people coming from Eastern Europe was so big because people are really trying to escape these countries simply because life is difficult. So they don't have a lot of children, one, and two, life is very hard and they're trying to escape. And so normally they cannot just enter any country because you need a visa to be accepted. So that's why they were repelled at the German border. But many students from these countries, they think, okay, I go study abroad. They go to France, to England, even to the US or Canada, and then they say, oh, it's pretty good here, so I stay here. And they don't go back. So again, these are countries that are going to be more and more old as time goes on. Spain and Portugal are a bit sad. So I think it's a combination of low fertility again and low immigration. Italy is clearly a case of low fertility, which is again completely different from our idea of the big Italian family with many people. So I don't want to say I have stereotypes, but sometimes in movie that's the type of families we see as traditional Italian families. Well, now again they are below replacement, and population is going to shrink. Yeah, so is that? Yeah, that's more or less it. All right. So, any question about this thus far about population? No. Okay. So now we have until right 5, right? So we can. We could take like 2 short breaks or 1 big break. What's because I'm done with population, so we're going to start finance. So I think it's not a bad time to take a break right now. We can say something like 7 minutes maybe, and then we come back and we continue. All right. So let's say 7 minutes.
Excuse me.
Oh yeah, go ahead.
Will you give us our grades for the,
Oh,
for
yes.
the exam?
Sorry, I didn't think that. Yeah, I should have thought that's the thing that you had in mind. So there's one grader who still have to give me the copies, and once I have everybody's grades, then I'm going to give them to you.
Okay, thank you.
And for the problem set?
Oh yeah,
The
and
same?
same thing. Problem set, I don't have. I have fewer grades, so. But so okay, just as an idea, I'm not super happy with the grades for it's okay, you know, it's above passing average, but yeah, it was I guess it was a bit more difficult than I thought the exam, but it's fair. But obviously for the problem set, the grades are very close to perfect because you had time and yeah, so you shouldn't worry about
The
that
exam
too much.
is not good.
It's okay. It's just maybe last year it was like one higher or something the average. So
For now, what is the average? To have an idea.
So I didn't compute it, but yeah, I think it's no, I don't remember. But
Okay.
I know that I think it was a bit lower than last year. But yeah, no worries too much. Okay, so back in 7 minutes from now. Sorry, I didn't think the time had passed so fast. Okay, so let's finish this. Okay, oops, let's yeah. So OLG models. So now we're going to go to a totally different set of topics, but I think it's nice to change for a while. Otherwise, it wouldn't be topics in macro. It would be growth if we just had growth all the time. So I just changed the last chapter on the website, or did I? Or maybe I did. Maybe I intend to undoing it. I'm going to explain why exactly. So last chapter is on hyperinflation. It's an extremely interesting chapter, but the model I thought was a bit well, it has some positive and less positive aspect to it. So I thought, oh, maybe I should try and change the last chapter on hyperinflation and do something else, and maybe do other more overlapping generation models. But as I was digging into that, I realized that it's rather complicated, and for doing that basically in 1 week or 1 week and a half, it would have just passed you over the head, and you would have had a very hard time to understand them. So it's really something that I should present at the master's level, not L3. So I decided it's a very good set of ideas that are presented in the last chapter on hyperinflation. So I want to keep it, but I'm going to explain to you the positive and the less positive side about the model. And actually, it's a good way for you to understand where these models come from. So you're going to see that the two models, so the model of today and of the last model we're going to see in the class, are rather old models. So this literature has existed for a while, but still there are very, it's a good way to look at where things were in the past and where modern models in macro are going to be in the future. Okay, so just before starting with that, let me start by telling you a story. And then you can think for a bit about it. That's a way to have some concrete example in your mind, because otherwise it can get very messy. So back when I was a student, we had to buy textbooks. So I don't know how many in how many class you had to buy a textbook. Sometimes people ask me which textbook should I use for this class. I didn't really use any specific textbook. I think the set of slides are perfectly fine. But back in the days, it was very fashionable for professors to just say, oh, you have to buy this textbook, and it's 150 Canadian dollars, which would be like 100 euros or something. It was, or maybe I'm exaggerating, maybe it was 70 euros. But so imagine you have like 4 classes in which you have to pay 70 euros for a textbook, and you're a poor student and all you eat are noodle every day, then it's a big chunk of money. So that's some decision that you have to take. Oh, should I or shouldn't I buy the textbook? And especially, I don't want to buy the textbook if I don't think I'm going to keep it for the rest of my life. I want to sell it back. So there was this secondary market, which was a market to so buy the textbook from the previous generation of students. use a textbook for one year during the class, and then sell the textbook again for the next generation of students. So now my question is the following. So here's the model. So imagine that the textbook on the used market have a certain price. They don't lose value if you use them. They just keep the same price forever. Like the condition is the same. Basically, you treat your book very well. And then you're poor, so you're thinking, okay, well, if I can buy a textbook and resell it next year, fine, I think it's worth it to use it. But if I cannot resell it later, then it's not worth it because it's too expensive and I know I don't want to keep it anyways. So I'm just not going to buy it and try to make it, to study without it. All right, so that's your preference ordering. So the best thing is if I can resell the textbook, it's worth it, I buy it. If I cannot, I don't buy it, okay? And now I tell you the following. So the first week of class, the professor says, oh, we use this textbook, but by the way, so in 3 years, they're going to change for the next edition. So, and there's a bunch of things that's changed. So you have to, you're one of the last generation to buy this textbook. And then in 3 years, I'm going to change it. So then my question to you is it worth it for you to buy the textbook or not? So there are a lot of moving parts. So think about the story in your mind. Would you buy it or not? And of course, what you know is all your fellow students are like you. So they have the same calculation in their mind.
But what is the alternative?
So if you don't buy the textbook, then you have to study without it, and maybe you fail the class, maybe not. But
okay,
you would prefer to buy the textbook and resell it.
You could probably find a version of it online that's been illegally uploaded.
Yes, okay, yes, I know that it's maybe it's even something that I may have done in the past, but that's not part of the model. So there's only one alternative is use textbook market or no textbook.
But since you're not the last generation to use the book, you could buy it and you are pretty sure that you could sell it to someone next year. But if you are the last generation before the change of edition, then you don't buy it.
Okay, good. We're getting somewhere. That's exactly the kind of question I want you to have in mind. So building on this, do we agree or?
Maybe having an old version of textbook is still better than having nothing. So you could still buy it at a lower price.
Yeah, but so in your mind, do you buy it and sell it after or not?
Depends on the price.
Yes, no, but I'm telling you, for instance, the price is always the same each year.
Oh yeah, then no.
So why wouldn't you buy it?
Because I would probably, if everybody thinks like me, I would probably lose some money. Because then the book will have lost its value in the sense that it will be less useful for studying.
Okay, can you, sorry, can you say more explicitly what you have in mind? Or anybody. So, so the first answer was really going in the right direction. There's like one missing link. So I'm just going to reiterate the first answer was, okay, if I know that next year they're going to buy the book, then I should buy it and sell it back. But if I know that like in 3 years, and I'm not going to be able to sell the book because it changes, then I don't want to buy it. So,
But if you do this, you move the problem over time because it's just gonna change it to 1 year before, and you will still have people in year -2 deciding not to buy it because maybe they won't be able to sell it back in year -1.
yes. So then what do you do?
But I'm thinking this would have an impact on in the price on the previous year before the deadline.
Yeah, okay. So that's exactly right. So it's thing is at some point the price changes. So that's the thing. So the question is, how will the price change? So so the first answer was exactly right, but you just have to think, okay, I know I can sell it tomorrow, like for next generation, because they can't buy the textbook because they use some different one. Then that changes my attitude towards my predecessors, and the predecessors, being rational, they foresee perfectly the future, and they see, okay, next year they're not going to buy it, therefore I don't want to buy the textbook from the previous generation, and on and on and on. So what that means is that at the exact moment when the professor says, so imagine that students have this in mind, that the textbook is always going to be used, then there's no problem. Each generation sells the same textbook to the next one, and there's no problem. But at the moment when the professor says, oh, in the future it's somehow not going to be valuable, then that changes the attitude for everybody. And right now the prices will change, because right now I know that I'm not going to be able to sell it back. So the only thing that I would be willing to pay is the so exactly, it wouldn't be zero, but because there's still some use to me. But I know, okay, maybe I would have sold it for $40 next year. I know that for next year the value would be zero, so that now I have to subtract 40 from the price I would have been willing to pay. So if I was willing to pay yeah, I would have had to subtract the anticipated value. But yeah, now it's getting into I need to have a model in order to not say stupid things. So we're going to go on and introduce a formal model of what we're doing. But so this is just to put in mind in your mind two things. So in objects, there are two sources of value for the object. One is the real economic value of the object, what I get from using it right now from holding the asset. So if it's an asset, for instance, so if I buy some equity in a firm, for instance, so I become a part owner of that firm, then that firm produces, it's something that has some value right away, because that firm is producing some values. But also what I know is that if in 2 years I want to sell back my share of that firm, then it's also going to have this, what we see, this speculative value, this value that comes from the price that I anticipate that I can get from other people. And the fact that the professor says, okay, I tell you that in the future it's not going to have any resale value, then that affects the price, the market price right now. So it means basically that the professor should never say, I tell you that in 3 years I'm not going to use the textbook. However, there is one solution for this conundrum. I haven't modeled it, but I'm pretty sure it's right. It's to never say exactly when you're not going to use it. So if you say something like, oh yeah, maybe I changed my mind and next year I change the textbook and you can resell it, but maybe I don't change my mind. So in that case, I think it still affects the price that you are willing to pay, but it doesn't drop to a very, very low value because it's some risk that you have to keep in mind. It's a bit like depreciation, basically. It's like, okay, there's some part of instead of your book being destroyed slightly, so instead of that, it's okay, there's like 10% chance that I can't resell it. So it's a risk that you have to keep in mind, but you could go on forever. So I think in that way, in that case, it would be fine. So that's it for the introduction. But so that was an introduction to what we're going to see now. So are we going to look at the market for textbooks? No. We're going to look at the market for money. Because what's enigmatic about money is that, so textbook, there is some economic value because I gain something by using the textbook. It's not like I just keep it on my shelf and not use it and wait to sell it back. No, it has some value of using it. Even if as was said, even if I can't find any buyer for it, there is still some value for me to having it because I can study with it. But money, is there some value to having money in my pockets if at some point I know that people don't want it anymore? Well, no. So money is, because I can't eat money, I can't plant it in my garden. It's not going to be useful as a fertilizer for producing plants. So the only reason that I would like to have money is to be able to use it to exchange it for something else. But then the crazy concept is, why is that the case? Why is that the case that people trust that they can always find somebody else to exchange back money? And this was, for economists, this used to be especially an enigma in terms of intergenerational value of money, because so back in the days, you used to have many episodes of hyperinflation, even so like in Germany, for instance. So then people were like, yes, of course, it's possible that people just lose trust in money. So if I think that there might be a hyperinflation episode in the future, then why would I hold on to money right now? I know that it's worthless. I should hold on to something else. I should hold on to something that allows me to produce something, for instance. This I know that it's always valuable. So, and the way we're going to look at this, so we're going to look especially at the link between money as a speculative asset and inflation. So how so inflation, by which I mean the value of money over time. So why does money always keep its value over time? Why isn't there crazy high inflation, for instance, or other answers? So here's our model. Yeah, and so to have a link with the previous discussions that we had. So back in the days, you didn't really need money because you didn't really need to save in a retirement account or anything. You could just have children. So when you're young, you have children, and then when you're old and you cannot work on your farm anymore, then don't worry, your children are not going to let you die of hunger. They're going to work and give you some part of their production to allow you to survive. So that's the model we have. So we have a model that's populated with young people and old people. And the reason why, so back then, so the reason why we didn't worry about old age back then is the kids could support the parents, or they could hope for just charity from younger generation. But of course, if they're not your children, then maybe it's less obvious that they're going to help you survive. But nowadays, we have a different scheme, which is private savings, private pensions, and public mandatory pension system. But in all these systems, it's always the same thing. So the young generation produces goods that are consumed by the old generation that are retired. And the young generation also invests in the future. Why? Because they produce some goods that are consumed by the old generation, but they also collect tokens that reflect their production. And what are these tokens? That's money, that's savings, that's a number, a virtual number in your saving account that says that yes, you have this money, and when you're old, even if you're not working anymore, you have the right to use it to buy stuff. But the thing about these systems is that they are all purely speculative. Yeah, some people have example of purely speculative systems or purely speculative assets?
Maybe Bitcoin.
Yes, exactly, Bitcoin. We're going to look at that. Others? Or not necessarily asset, but cases in which things are really have a purely speculative value that's disconnected from their real value.
I mean, maybe for gold, the market price is higher than the price it would have been if it was just metal, like for iron or silver.
Yeah.
But I think it still has some industrial value.
Okay, it's perfect answer. So exactly right. So the thing with precious metals is that they are useful. So people want them to use them in jewelry, and people want to use them in the industry. So even if for some reason the whole financial system collapses and the euro is worth zero, if you have some gold, you have some chance that you can find somebody who's going to say, yeah, I want to build something with gold or use it in computers or something. So, but you're right, it's also possible that we can just exchange it and the price of gold may fluctuate for some other reason. Yeah, other ideas? No,
Maybe stocks,
yes,
which do not pay dividends, because you're just expecting them to either pay them in the future or, yeah, no, just pay them in the future.
Yeah, so stocks pay dividends, but I understand if you invest in something that doesn't give you any income in the present, so all you care about is what somebody down the line is going to pay me for it, and you hope that they still want to pay you for it. So yeah, other example I had in mind was situations like asset bubbles, for instance. Well, that's more or less that's linked to what you said. So if you can imagine that there's some new trendy firm that is just founded, and then right away people think, oh, it's going to be the next big thing, and they invest a lot in them. Actually, the big tech companies nowadays, they have very little income because they pay very little dividend because all they do is they take over the market. They replace, they disrupt. So Tesla or Amazon or so Apple is very profitable, but these other giants, they invest a lot. So and yet their stock value is through the roof. Why? Because it's always because you have the promise that in the future they're going to be so dominant that they are going to pay back in the future. So they don't even need to pay back right now to have such a high stock value. Just the promise of having such a high value in the future is enough. Sorry. So another example is Ponzi schemes. So Ponzi schemes. So do somebody know what Ponzi schemes are?
Yes.
No.
So okay, next question. What is a Ponzi scheme?
It's like a hedge fund, but they don't really invest. They just receive money, and to pay the precedent shareholders, they use the new money. And so at one point it collapsed because the inflows of money get smaller than the outflows, and you know it.
Yeah, it's perfectly good. So yeah, one of the most famous of this situation was Bernie Madoff in the U.S. So his scheme was very good. So he says, "Oh, I'm just going to to go and target billionaires or super rich people, and tell them, oh yeah, if you invest in my fund, you get an extremely high return for sure." And who wouldn't want to invest in such a fund? If you invest in the bank, they give you a few percentage points of interest at most. Uh, so yeah, back then they still had some inflation. So it was. I don't remember his returns was 20% or something crazy. And then of course you always get new customers, so it's you can just use the new customers value to pay back the old customers if they want their money. And then at some point, yeah, he ran out of money, and then everybody saw that they just lost all their savings. um, yeah, another kind of asset bubble would be it's a different kind, but you could think of pyramid schemes too as like something like this, because what they say is, oh, if you invest by buying the products to sell, then you're going to become rich, especially if you get new customers, that the new sellers. So the sellers are the customers, but then what happens is pretty quickly you ask all your family members, and they say, no, it's a pyramid scheme, I don't want to do anything with it. And then you're stuck with the 1,000 bottles of shampoo to sell, and you have no clients and no other sellers, so you just lose your money. So it's again the value that you paid, thinking that you would sell, quote unquote, this idea to other sellers, but you couldn't find them, so in the end you way overpaid. So what is so back to asset bubbles. So one of the first asset bubbles was tulips. The story is simply that in the Netherlands, so they were extremely rich back then because of the trade and all the colonies they had. And then at some point there was some fungus and that attacked the bulbs of the tulip, that made the tulip had some strange colors that became fancy. And then people realized that if they had this sort of bulbs, then they had many people who wanted to buy it. So then they said, okay, I'm just going to buy some bulbs and find some gardener who's willing to pay even more for the bulbs. But then they sell it to the other guy, but the other guy is not a gardener who wants to plant them. It's just another person who thinks he's going to do the same. And since the price at every operation goes up and up and up, so people think, oh, it's going to go up forever. The problem is, yeah, the disconnect between the value of having some tulip in your garden and the crazy value of the market. And one rule that they say about asset bubbles is they can't go on forever, and what can't go on forever will stop. And it stopped, and yeah, that crashed, and that was the first asset bubble for tulip bubbles. Bitcoin could be seen as a potentially a bubble, or having had some bubbly past. So we're going to see more clearly what's going on with Bitcoin. All right. So for now, what we're saying is, yeah, money is purely a speculative asset, and still the young generation is willing to accept money for its work, and in the hope that they can with the old generation do the same thing, so they can give back the money when they're old, so they can receive some consumption from the next generation. And what is key here, to link this with my story about the books, is that you see that there's this disconnect here. You can't say to the old generation of students, oh, I'm going to take your book for a while, use it, and then sell it back again to you, and we're going to sell a contract, because these people go away. They're not the people who are going to interact with you. You have to trust that there's this next generation of students that are going to be willing to buy the textbook. So it's purely trust that you put in the system that it's going to work. So the money is the same thing. You accept money right now purely based on the trust that it's going to keep its value in the future. All right. So this question was first. So very good step were made by two economists, Paul Samuelson in '58 and Maurice Allais in 47, and both discoveries were kind of made independently. So Paul Samuelson said, "No, I didn't know about his work, so fine." We see that both of them worked independently. And here we're going to have a setup that's adapted by from a handout by Thomas Chani, which was the first teacher who taught this class. Okay, so let's go ahead. So in the model, he has a model with 2 or 3 time periods. So I'm talking about Paul Samuelson's model in his original 1958 article. Oh, by the way, I should just say that Paul Samuelson was like a giant in the economic profession. He wrote, I think, the most successful economic textbook of all time. And yeah, he's the reason why you have to use math in all your economic models right now. So before him, it was kind of facultative. You could use it, but people still sometimes wrote like huge essays to explain their ideas with little formulas. So it was not all that clear how everything was working out, but he really made sure that now everybody knows that you have to use math in your economics models. All right. So now we just need a 2-period setup. It's enough. Of course, so the time periods are discrete. So you have t equals 0, 1, 2, 3, but we don't really care about which number it is. And we imagine that periods are like 30, 40 years. So people are never children. They never study. They just start their lives at like 16, and they start working. So they just have 2 periods: one active period and one inactive period. So old age. So we don't really imagine that they're. So when I say young, I mean young worker, right? I mean active. And then they are old. And now, where does the word OLG come from? Well, it's overlapping generation. It comes from the fact that I have to have a model with 2 generations that coexist within the same model. And this is, of course, a difference from the previous models in which we always had just one generation or one representative agent. And it was good enough to study all that's we have to study. Here, you're going to see that just by adding 2 generations, everything becomes not so clear. Because with one generation of uniform people, then it's very easy to decide what's the first best. First best is you maximize the utility of this representative person, and you maximize the utility of everybody. So here, with 2 generations, then right away you have to think, okay, how do I value each generation? How do I discount the future? It's not all that clear. And sometimes, especially in more complex overlapping generation model, it's possible to get inefficient solutions that we know are inefficient. So in terms of the free market, and in which the government would have to intervene to reestablish efficiency. Don't worry, it's not this model is not too complicated. Right. So now let's introduce the goods. So goods is what people produce and consume. So here it's not like the solo model. We don't have investment. So the good is you produce something and you consume it right away. So for someone born in period T, so you write with a subset T. So when I say we have discrete time periods, so T is going to represent the period at which you're born. So for a period, for a population that is like a generation that is born in period T, so its production in time S is omega T of S. So you see that you could potentially have different things going on. So you could imagine that people produce when they are young and when they are old. So it would mean that the omega T of T would have some positive value, but also omega T of T plus 1 would have positive value. So it would mean that somebody born in period T and but being in period T plus 1, so being old, would still produce, for instance. So this is just to say that we have some general notation, but obviously we're going to simplify it. And then the consumption in time S for a generation born in time T is C subscript T of S. And again, S of is obviously a discrete number, so it's period 1, 2, 3, 4, 5. And it can just be T or T plus 1. So Ct of T and Ct of T plus 1, because T plus 2 you're dead, and T minus 1 you're not born yet. Okay, and now what we're going to do is introduce our simplification. So we say that where they are young, then they produce some output, omega T of T, which is just equal to some value omega. And when they are old, then they do not produce anything. So omega T of T plus 1 equals to 0. And then here's the thing. So the goods are fully perishable. So it means, so any good that is produced at time T has to be consumed at time T. So the result of that is that goods are a purely speculative asset. Oops, sorry about that. Okay, yeah, goods are a purely speculative, not speculative asset, economic asset. So why? Well, we hold these goods just for their use because we know that we cannot resell them. So we cannot worry about how is this going to be valuable for the future for the next person. So like a house, for instance, a house is really a type of good that has these two types of value, an economic value right now because I'm using it to live inside it or maybe to work from home inside it. But I have also to worry about the value of that I'm going to be able to resell it for the next person who wants to buy it. Here it's purely economic because if I don't consume the good, then it's just lost. So obviously people are going to consume everything that they buy. All right. Any question about goods? Yeah, so now we're in the difficult time, difficult part of the class because we introduce a bunch of notation, and you have to wrap your mind around all these new letters, and you don't know exactly where it's going. So, you know, when you do exercises, you're going to be more familiar and think it's not that complicated. So now just yeah, bear with me, and if ever you have a question, then don't hesitate. Okay, so that's goods. Now we're going to see population. So the population is not one person, one representative person, but some population LT. So L for, let's say, labor. So the amount of labor in period T. Yeah, and we're going to see that population grows at a constant exogenous rate n. So we have LT equals 1 plus n LT minus 1. So is that exponential or not? Somebody say yes or say no.
Yeah, it is.
Yes, it is. Okay.
Is always n.
Yes, perfect. And if I want to look at it, t plus t equals 10, for instance, then it's just 1 plus n to the exponent 10. Yeah, so that's exponential growth. And also, the thing is, we have that n is not only 1 plus n is not only the rate of growth of the total population, but what you have to keep in mind is that LT, the population at time t, is actually two subpopulations. So it's population that is born, let's say, yesterday, that is old right now, and population that is born today, that is that is young right now. And what we can say is that not only is 1 plus, so n the rate at which the total population grows, but it's also the number of children that each person has on average in its life. And the proof is very simple. So here it is. So normally I would do that on the board, but I changed it because yeah, it's complicated to do that in LaTeX. So here is how you would prove it. It's very easy. So population today is equal to 1 plus n times population yesterday. So population today is LT and population yesterday is LT plus LT minus 1. But imagine that, so we replace LT and LT minus 1 by these two subpopulations, and we say that PT is the population that is born at certain period t. So it means that the population today is PT minus 1 plus PT. So it's equal to 1 plus n times the population yesterday, which is PT minus 2 plus PT minus 1. And then imagine that this rate of new children is 1 plus m, but we don't know m, and we want to find out what it is. So what we can do is do the following. So say that PT, the population that is born today, is actually the children of the population born yesterday. So how many person do I have that is born today? It's the population yesterday times the number of kids that they have on average, so 1 plus m. And this is equal to, same thing, 1 plus n times, and then we do the same thing. So PT minus 1 is actually PT minus 2 that must multiply by 1 plus m. And then what you see is we can just take the 1 plus n and multiply everything, and we get 1 plus 1 plus m, so 1 plus p t time t minus 1. That multiplies 2 plus m, which is equal to, again, we can do the same. So let's put the pt minus 2 in front and out of the parenthesis, and we get 1 plus m, so 2 plus m. And then you see that we can just divide by the 2 plus m on each side. So we get that pt minus 1 equals to 1 plus n times pt minus 2. So this was our rate of growth for, so we had that here. So pt minus 1 was equal to pt minus 2 times 1 plus m. So it means that 1 plus m has to equal 1 plus n. So m equals n.
Sorry, I don't understand why pt minus 1 become 1 plus m at the last on the last line.
Okay, yeah. So it's yeah. Okay, I should have. Let me just. So these are different. Okay. Oops. Sorry.
Oh, okay.
So it's just a conclusion. So yeah, I should have left a small gap to not confuse you. Sorry. So it was our first our assumption was that t minus 1 is equal to pt minus 2 times 1 plus m. And now we find that pt minus 1 is equal to pt minus 2 times 1 plus n. So of course 1 plus m has to equal 1 plus n. Oh, I don't control my keyboard well. I keep you losing my hand. Okay. So this is the setup for the model. So you see, I think it's not that complicated compared to the solo model. Okay, so foreseeable future. Well, of course, the old people do not produce. Why? Because omega t plus 1 equals 0. So by assumption, we assume that they produce nothing. And then there's a problem. So in that word, I didn't say there was any asset whatsoever to trade. Okay, so it means that they are stuck really, because and of course, well, I didn't say it, but you imagine that they don't have a family necessarily, and people just care about themselves. So what does that mean? Well, it means that there's nothing that some young person can do today. So imagine I'm a young person. So I'm living my life and producing, and I'm happy. And I would like to be able to have in some way to convince the next generation of young people to pay me in the future. And I'm ready to pay somebody something. But the problem is that everything that I try to give people, or that I would want to give people of the future, is going to disappear, because as we said, consumption good is perishable. So there's no way for me to do that, and there's also no way for me to write a contract with anybody, because right now all I have is old people around me that were there yesterday, but they're going to die this year, and then they are not going to be there. So next year is a new, not next year, but in 30 years or 40 years, it's going to be a new generation. And they haven't asked anything, they haven't signed a contract with anybody. So because of this, the absence of asset that is durable, then like a house or any other type of asset that I could trade with a young generation, then I'm stuck. Really, I cannot. So the only thing I can do is consume all that I produce right now and just wait to die of starvation tomorrow. So it's a very very nasty problem. That's what we call the contraction problem of the free market. So the young in period T, they would have to lend consumption goods to old people in period T and hope to be repaid by the young people in period T plus 1. But the problem is that the old people would like to say, oh yeah, I promise you that this young person in next 3 years is going to pay back if you pay me. Like, generosity pays back, for the universe is going to pay you back for being generous. Maybe, but I would prefer to be able to sign a real contract if I didn't trust that people are generous. So in this model, really, there's just nothing you can do. So that's the key insight of Samuelson, is saying is that, well, most assets that we have are actually not durable. So it's food or it's clothes, and in 30 years, I can try to sell back my shirt, but not a lot of people are going to want to buy it. So people want something that's durable and exchangeable. So what do we need? Well, if we have our house or something, but if we don't have that, then we actually need to invent something. And this something is, you see what where I'm going from. I'm going there.
Money?
So yes, good, exactly. Solution is money, which is a virtual store of value. So money has, as we said, no intrinsic value, but so it's purely speculative. It's pure. Why would I ever want to keep money around? Why would I ever accept money? It's purely based on the belief that somebody is going to be willing to exchange it back to with something else. So that's why we see it's a purely speculative asset. But so the key difference with the good is that actually money is non-perishable. So we could add to the model some non-perishable good, like houses, for instance, that you could exchange with the next generation. But you see it's kind of redundant, or you could see what's going on if you add it. But with this, we have the two things we need. We need something that's valuable to consume, it's the goods, and we need something that's durable, that allows me to speculate about the future value. So that's money. So the scheme, quote unquote, is that, of course, the old people can give the young people of today money in exchange for consumption goods. So if I'm young, I work, and I save part of it. And what is saving? Well, it can be anything, but if it's money, then it's just that. So I produce more than I need right now, and I exchange it for money that the older generation is willing to give me in exchange for good. And then when in 30 years, 40 years, I am old, then I trust that the next young generation is going to say, oh yeah, that's a good scheme. It's what people have been doing forever. So let's continue to do that, and it's perfectly fine. So we see it's a purely speculative bubble because it's the asset money has no fundamental value, and it's speculative because it's based on the expectation that the next generation is going to say the same thing. But so imagine the following. Imagine that so I'm working now, and you're going to start working too, and then we just decide that, oh, let's just say that the euro is not worth anything, and we just print our own money. So then the old people that are retired and they have money, so they want to exchange back the money, and we tell them, oh well, no, we just consume everything we have, and also we created our money, and all we have to do is convince the next generation when we're old that our new money is the right money, so they're going to be willing to give us some consumption good. And then what we did, well, we consume all the things that we produce right now. We didn't pay back the old people of right now, and we get the consumption of the future generation because we convinced them that our money was good. So you see what we did there? We just created some new asset that didn't exist before, and as long as we trust that it's going to have value in the future, then fine. So why wouldn't we be able to do that? Well, we wouldn't be able to do that because it's risky, because the next generation might say, oh yeah, that was a pretty neat thing to do, so let's not pay them with their money, let's invent our own money, and so on and so forth. So basically, you need some more solid ground in which to believe that the money still has value over time. So it has to be based on. So we have to say that. So it's a speculative asset bubble, but it's still going to be worth something. Yeah. So do you think that money is purely speculative or not? So is there some reason to keep it or not? Or actually, while you think about it, I'm just going to fill in my bottle because I don't have water. Yeah, so this is one advantage of Zoom is I'm at home, so I can fill my bottle. So somebody has an idea why has money value? Why do we keep it?
Because people trust it, trust the money.
Yes, but why do we trust that people trust it?
Because it is enforced by public authority.
Yeah, that's a very good point.
I mean, money is still backed by bonds, I think, the central bank's balance sheet. So if I would like lose confidence in money, I could still get bonds back. But if the bonds give me more money in the future, yeah, I don't know.
Yeah, you could see that for liquid money, but so you have to think that the bonds are based
still
on
money.
are still based on the national money. So, but if they were backed by something else, like gold, for instance, then okay, you trust. Okay, I can hold this money because perfect. I can always go back to the central bank and say, oh, I want my bag of gold instead, and they go inside their vault and they give me gold. But that's not anymore the system, but it used to be that. So these are all good answers. Yeah, so let me give you my answers. Yeah, so the advantage of money is two things. Well, yeah, actually, I should have written something else. Yeah, it's legal tender. So that's oh, why didn't I write this? Yeah, okay, so three things. So trust, the first answer was pretty good. It's because I trust it because other people trust it, and other people trust it because I trust it. Perfect. It's just once trust is established, it's established, and it just goes on forever. Two is by law you have to pay your taxes. You can't say to the government, "Oh, I don't want to pay you with money. I want to pay you with tires because I produce tires." Well, no, the law is you pay your taxes in money, so you need money to pay them. Yeah, and the third reason is the law is you can refuse to do some transaction is in something if you're some commerce, but you should accept money. The money is like the lowest. It's if somebody wants to pay you in money, it's well, you can always refuse, but in general, it's accepted as the legal currency. Yeah. So
do taxes really create trust in money? I mean,
oh yeah, because it's again. Well, if I work, say I work at home and I produce my stuff, well, the government says, okay, well, you produce some work this year, so now the law is you pay me. And to be able to pay me, you need some money. So it means that if I have a bag of money, then and I'm not too sure if I can find somebody who needs it, I go to somebody who hasn't paid their taxes yet, and I say, oh, you need to pay your taxes, so exchange me your tires for my money, and then you can pay your taxes to the government, for instance.
But isn't that quite limited? Because like I know that in some Latin American countries, they just want the little bit of money of the country to pay the taxes, and then they want like dollars. Or...
Yeah, it's not a huge thing, that's for sure. The biggest thing is trust, but you just add this little element. Oh yeah, so probably I'm going to find somebody, maybe, and then because of that, I trust that my bag of money is going to be good, and then other people trust because I trust that, and then trust is established. So, but I agree with you. It doesn't have to be something, and actually, that's exactly what we're going to see down the line. Yeah. So this is just a quote that was misattributed to Benjamin Franklin. Was borrowed from a guy named Christopher Bullock, and he says, yeah, two things are in this world are unavoidable: death and taxes. Everybody has to pay their taxes. But yeah, it's possible that even national money loses value. Now we go back to Bitcoin that was mentioned initially. So Satoshi Nakamoto, well, nobody knows if he exists or who he is exactly, but this is one thing he writes in his paper is the root problem with conventional currency is all the trust that's required to make it work. The central bank must be trusted not to debase currency, but history of fiat currencies is full of breaches of that trust. So you're right. In many countries, and in Latin America, in Argentina, for instance, they have, in Brazil, they have had for a big swath of their history a huge problem with inflation because people stop losing faith in money, and sometimes government overprint money. So then the money is debased. So okay, but so I agree with him. But so what's his solution? So his solution is, oh, I'm going to create some virtual currency. So first of all, this virtual currency is more or less exactly like the scheme I was suggesting before. So we just invent a new currency and we say it's worth something. So we didn't have to work to invent it. It's just we declare that this is it. And even Bitcoin, it's even better. You don't even have to print physical bills. You just have to say, yeah, it's some virtual store of numerical value, and that's it. If the ledger says that you own some Bitcoins, then people who have who want Bitcoin can pay you back money, and you can pay them Bitcoin, and that's good. So so it's a genius thing if you can manage. So imagine the person who really invented that and declared, oh, I'm just going to attribute myself 50% of all the Bitcoins. And now if Bitcoin is worth, so let me show you the value of the Bitcoin. So if Bitcoin was like worth 15,000 euros at some point, so it's just if you just declare that you own half of the Bitcoins, then okay, you're crazy rich. So that's why the first people who got in the Bitcoins are crazy rich. But then his idea is, yes, it's better than fiat money because people lose faith in government, so they debase their currency. So it's true for some countries, but as you can see, it's not necessarily true for a country like the US, for instance. So the US dollar is pretty stable, whereas the Bitcoin is not that stable. So you can see, so this is on the left. So this is how many US dollar you receive, how many euros you receive per US dollars, and here is how many euros you receive per Bitcoin. So you see that yes, it's not as stable as before. What's going to happen with Bitcoin is, should I trust that if I buy Bitcoin, then it's going to be good in the future or not? Do I have Bitcoin investors in the crowd?
Depends if you believe that people will trust and use it or not.
And do you?
I don't.
I should have made a survey about this. So you think Bitcoin is going to crash in the future or not? So another opinion? Well, I personally used to think exactly that. I used to think no, Bitcoin is going to crash. There's no reason why it wouldn't crash. But then let's go back to this observation that we had before. So, oh, I need to pay my taxes, so I need some money. So maybe I find someone who's going to be needing money. So maybe that's enough to keep the trust. Now I think the same thing. I think that why is Bitcoin never going to go down to zero? It's not because of course, yeah. So the problem with Satoshi Nakamoto is he doesn't understand what money is. So money is purely speculative. So no matter if you decide, if you just write in your code base that there is a certain number of Bitcoin and it's always going to be that, therefore you cannot have inflation. Well, yes, if people just decide that they don't want Bitcoin, then the value of Bitcoin is zero. It's just a convention. It's just so. But the thing is, the people who buy Bitcoins and who create Bitcoins, they're not economists. They're computer programmers, and they're in love with their invention. That's a super nice technology. This kind of decentralized way to exchange value without having any need for a bank or anything. But yes, so they're kind of mistaken in their idea that that's all you need for something to have value. No, for something to have value, you need to have some use to it. You don't with Bitcoin. So what you need is some speculative value. So then why should we trust that Bitcoin is going to have a speculative value? Because of those computer programmers. Because I trust that whatever happens, there's always going to be some become an enthusiast somewhere that is going to say, oh yeah, it's going to go up again, I can trust it. So if I trust that I can find some of that person that would want that to exchange Bitcoin with me, then that's good enough. Then other people can trust that I trust that, and they can trust that I'm going to accept their Bitcoin too, and it can keep its value. I'm not saying it's going to be stable, as we can see. But you see that trust can. So it's like the professor who says, "Oh, I keep the textbook," or "I don't keep the textbook." It's just a small word, but that's enough to change expectations about the future. And expectations are the only thing that we have for speculative assets.
Excuse me.
Yes.
It's just that I think it only exists because, on the other hand, you have other currencies that you can use in your everyday life, and so if it wouldn't be the case, nobody would use a currency that is not stable like the Bitcoin. And so it only exists because it's not the main currency people use to shop.
Well, I
Otherwise,
agree.
it
I
would be
agree with
as
you.
in, you know, the Latin American example, and people would use other currencies.
Okay, yeah, I agree with you that it's impractical. In fact, in Bitcoin conferences, people are usually not allowed to pay in Bitcoin because it's too complicated. So that's it shows you that it's doesn't it. So they initially they really wanted to just replace fiat currencies, but it's still complicated to do these transactions. And I'm not entering into all the debates about the fact that the energy needed just to run Bitcoin is consumed as much energy as the country of Austria. I think it's just crazy. It's yeah, but yeah. So your point is essentially is that it's purely used for speculation and not for exchange. Yeah, but you could think that. So I could keep diamonds, for instance. So I'm not using, I'm never using diamonds, I'm using euros, but I keep diamonds because I know that at some point I can sell them back to some pawn shop if I need money. No?
Yeah, maybe.
Yeah, but one thing too that you could say is, yes, but I also know that I can always find some country in trouble that I can exchange my Bitcoin for. And right now, what country is in trouble? So you have two answers, two good answers. What countries have trouble with their currency right now? So I know that we are stuck in COVID, but you can.
Zimbabwe, I think.
Argentina.
Right now? Oh, I didn't know that. Is that true? Like this year or last year or?
No, I mean they've had problems.
Yeah, they've had problems. But Zimbabwe, yes, this year, and there's another one that's been in the news quite often.
Venezuela.
Yeah, Venezuela, exactly. Yeah, so it's for them. If I were in Venezuela or in Zimbabwe, and I had a cell phone, then I think, but between choosing the national currency and choosing Bitcoin, I would say, yeah, Bitcoin is impractical, but at least, yeah, it moves a lot, but it's not going to crash to zero next year. Whereas it's more complicated for the other currencies. All right, so how long do we have? Okay, we still have some time. So I think we'll go up to the quiz and then finish. Unless there are other questions about speculative assets. All right. If you have, you can ask. So this is going to be a recapitulation of your macroeconomics. So here we have our preferences over time. So that's, I care about consumption today and consumption tomorrow. And we're just going to say that this big U that represents my whole utility over my whole life is going to be simply utility in period one. That's a small u, that's function of consumption in period one, or in period t if I'm born in period t, plus a certain discount factor beta that's between 0 and 1. That makes me discount the future. And so my future utility is u of ct t plus 1, so what I consume in the next period. And yeah, so beta is between 0 and 1. Why? Because I care less about my future self than my present self, because I'm impatient and I like consumption right now. And then about this the assumptions for how I care about consumption. So u prime of c is larger than 0, and u prime of c is smaller than 0. So just to see if you're awake. So what does that mean in terms of marginal productivity?
Marginal utility is decreasing?
Yes, positive and decreasing, exactly. So if I consume more, so U prime of C, then it gives me more, but the more I have, the less I want. And if I use the U of C, then I can equals ln of C. Then what I could do is just so replace ln of C plus beta ln of C. And if I just took the exponential of this, yes, so it would give me Cobb-Douglas preferences. So that's ln of C is something that you can keep in mind. So it looks like this, of course, obviously. So that's how I care about the future. Now let's look at my intertemporal budget constraint. So now I'm able to have something going on with the future because I'm able to save money. So what's happening is instead of consuming CT equals omega, like I used to when I didn't have access to money, now I can consume less than omega and save it for next year. So exchange part of my work for some money. So M, which is going to be MT. So MT is the money that I acquire this period. By the way, it's different from the other M that I used just for my demonstration. Okay, so this is some amount of money that's going to be nominal. So it's just, you can think of as just bills in your pocket. And so, of course, has to be some rate of transaction between consumption and money, and this is going to be price. So in terms of money, the price of the good at time t is P of t. And usually we have small p's, but here we say it's super important, so that's why we have capital P. So we care about the price a lot because it's a model about inflation. Yeah, by the way, so we first took, I came back a bit late, so it was more like a 10-minute break. So yeah, I think what we can do is just forge ahead and finish earlier, then take a second break. I think it's, unless somebody's going to die if they don't have a second break, then say it in the chat. Okay, and here's a very, very formal way of presenting it. So that's, if you're very smart, that's the way you do it. So, but obviously it's going to become simpler as we add some assumptions. But to be really nitpicky about the assumptions, so here they are. So the budget constraint in period T is, what I can do is, so first of all, I produce omega, and then I can sell back all this production. So I get, this is the amount of money I have for today. And then I can sell it back right away and buy some consumption. So spend PTCT and get essentially CT equals omega. But also what I can do is not consume it entirely and save part of it. So save MT here. So we say that PTCT plus MT is smaller or equal to PT omega T. And we don't say that it's equal yet, because who knows, maybe I throw away consumption in goods in the garbage. Who knows? But we're going to add some other assumptions, of course, but for now, we don't know. So we have this, smaller or equal. And the budget constraint in period T+1, then what I have in T+1 is the amount of money I saved, MT. And then there's no decision, really. I just take this and I hope I can find some young person that's producing stuff that is willing to exchange it back. So, and what do I get here? Well, the price is the next period price. So in 30 years, what is the price level PT plus 1? And this is going to dictate my consumption next year. So CT plus 1 is going to be MT divided by PT plus 1. And so I have these two other constraints that are the fact that I cannot consume more than what I produce. So simply 0 is smaller than or equal to CT is smaller or equal to than omega. So this just means that I cannot, yeah, there's no way for me to, actually, would there be a way to, oh yeah, there would not, okay. Yeah, so good question. So why do I have this? Why does it make sense?
Because you cannot say for another part of your active life, you're either retired or active.
Yes. So let me rephrase it. So why couldn't have CT equals 2 omega, for instance? So I know that in all my life, I produce omega amount of goods, and I would like to consume double. Well, I'm kind of saying it right. So that's because I cannot, so that's because I have, I cannot die in debt, basically. So whatever debt I had in the first period, then I have to pay it back. So what is the maximum amount of money I can save is 0. So I cannot save a negative amount of money. Otherwise, I would have to consume a negative amount next year. So by saving 0, I have MT equals 0. So I get that PTCT would be equal to PT omega. So CT would be well, smaller or equal to omega. So that's where it comes from. So yeah, it's just to say that I have to live within my means. And this, so by the way, it's going to give rise to this second constraint, but of course it's dictated by the first reason. All right. So the maximization problem is the following. So here again is to be extremely tedious in the way we present it, but we're going to simplify it. So imagine that I can choose CT of time t, CT of time t plus 1, and MT. So I can decide the 3 of them. So to maximize my utility, which is UCTT plus beta UCTT plus 1. But then, of course, I have a total of 4 constraints. One is redundant, but basically 3 constraints. So it's going to constrain the choice of CT, CT plus 1, and MT. And basically all the 3 of them are going to be, to boil down to a simpler problem. But if you don't understand economics too much and you're just doing mathematics, well, you are more on the economic side of things. So I trust that but if you're a mathematician, then you can use these conditions, the Karush-Kuhn-Tucker conditions, and check all the possibility of what you could do, and make sure that you find out mathematically the condition that makes sense. But we're not going to go into that. All right. So first of all, of course, as I said, I'm not going to throw money, to throw consumption goods in the garbage. I'm going to consume everything. So I can get rid of these smaller equal and get these, so my utilities, my consumption constraints are going to be saturated. So I can just have equals here. So then, and what I can do is then combine the MT, or actually use MT that is in both equation, combine them, and find out this simpler budget constraint that we're more used to, I guess, in the intertemporal choices. So this is the whole money I get within my life, omega, what I produce in period t, that I sell at certain price pt. This is of course empty. That is going to be equal to everything I can spend during my life. So if I consume in period t, then the price is pt. If I consume in t plus 1, then the price is t plus 1. All right, and then what I find? Well, I find that money is redundant on both sides. Well, actually not redundant, I mean nominal. So what I'm saying is I can divide by prices. So I have PT plus 1 PT, so I'm just going to divide by PT here and get this thing here where, so I had PT, it's gone, I have PT, it's gone. And here I had PT plus 1, so I'm going to substitute it by 1 plus pi t. And I get that, so pi t is equal to pt plus 1 minus pi t divided by minus pt divided by pt, which is the inflation rate, so the rate at which, so yeah, here I replaced it this way, so you can see for yourself that it makes sense. That if I replace pi 1 plus pi t here, then I would get this solution for pi t. All right, and as I said, so the last constraint is redundant. So then the problem becomes a simpler problem. So max CT CD plus 1 subject to 2 constraints here. So the constraint that I cannot live beyond my means, and that I have to respect my budget constraint. And then I did 3 potential solutions. So one interior solution. By the way, you have seen this model before, right? This intertemporal consumption problem.
Yes. Nico.
Yeah. Okay, so I'm going to test. So you should not have said yes, because now I'm going to verify whether you remember something. No, it's all good, because it's good to remind ourselves of what we learned. But because I've done some small quiz on that, and I realized that last year they struggled with it. So let's see how you remember it. All right, and we have 2 possible corner solutions. So usually we don't have corner solutions. Say if it's cup de glace, then we always consume something in both periods, but we could, in principle, decide to consume everything in one period or everything in the other period. However, what we're going to see is that only 2 of these 3 conditions are good. So intuitively, which are the interesting conditions that we should look at, and which one should we not look at?
The interior solution.
Yeah, so that's one. And then if I want to look at one corner solution, which one should it be?
But none of them is plausible.
Yeah, I agree that they are not super plausible, but
I
yeah.
think CT plus 1, you don't consume anything, you will die. So you will only live in ERT.
Yes. But then the other is?
You die from the scratch.
Yes. so that's why one is a bit less implausible than the other, because here you die. So there's nothing else to say. So yeah, you should start by eating something before you die. So that's why we're not really going to care about this one. But I agree that yeah, it's a stretch to. Obviously, that's a corner solution, though. So that's yeah, an extreme case. All right, so here it is. So this is the solution we don't care about. If I consume everything tomorrow and nothing today. And then this is what happens if I consume some of my stuff tomorrow and some of my stuff today. But then I could maybe have some corner solution, because I said that you could have a Cobb-Douglas solution utility that would guarantee an interior solution, but maybe not. So in that case, if you're if there's some crossing of the axis there, then you could imagine that if there's a very high inflation, so I mean that 1 plus pi t is very, very high, so the prices increase extremely fast tomorrow, then it looks like in that case I don't care about consuming tomorrow. I think, well, it's just going to be so expensive that let's just consume everything today and die. So let's live young and intensely and not worried like there's no tomorrow. So what did I write there? Yeah, so inflation rate pi t leads to an interior solution, but the lower value of money leads to a corner solution. So this is more tricky, so we're going to consider it later. Okay, so one last thing is possibility of interests. So let's just go and add this. So what if I could store some money and get some interest? So now we have assumed that when you save money, where is it? Yeah, here I save money MT, and I receive exactly MT in the next period. But maybe I receive some interest too. So here it is. So imagine that I receive MT, that's multiplied by 1 plus RNT, and N here is for a nominal. So it has nothing to do with the growth rate of the population. It's just to indicate that it's a nominal interest rate. So interest rate on the amount of money I would have in my pocket, for instance. In period T plus 1, of course. So then, oh well, I shouldn't have gone back. I just wrote it here, so I can modify very easily my two constraints. So here, the only thing is, yeah, the constraint in period 1 is PTCT, what I consume, is PT omega, what I produce, minus M, what I save. So yeah, before I had M equals PT omega minus PTCT. I don't remember what I wrote. Anyway, so that's a good constraint. And then the constraint tomorrow is, instead of being able to consume MT and paying PT plus 1 times CT, I consume MT plus times 1 plus RTN. So some bank somewhere or somebody somewhere gave me some interest. So then my new budget constraint is going to be the following. So here to do that, yeah, maybe I should have added some step, but you can see that what you can do is put MT there equals PT omega minus PTCT, and then substitute this MT here, and then divide by 1 plus RN. Oh, there's a T that's missing here.
But sir,
yeah, go ahead.
Well, what's the point of introducing interest if you cannot borrow money?
Perfect question that you go too fast, but that was going to be the point. But yeah, there's a reason. It's just we're going to see it later. It's just a way to introduce real interest rates. So real interest rates are defined that way. So it's interest rate where you have taken into account inflation. So it's 1 plus RRT equals to 1 plus RNT. Sorry, there should be a T here, divided by 1 plus pi T. So the real interest rate would be, so I can just do minus 1 on each side, and then I would get that I get 1 plus Rn minus 1 minus pi T. So it's so the 1 would cancel, and I would get RTN minus pi t. And since 1 plus pi t is close to 1, if, for instance, the time period is very short or the inflation rate is low, so it's close to 0, so I can approximate this by RTN minus pi t, because this is close to 1. So I say for a small pi t.
Excuse me,
Yeah, go ahead.
can you write the explanation between the links between the first line and
this and
the
this?
second? No, above.
This
Yeah.
and this?
No, above. Just how you obtain the second line.
Oh, it's just a choice that I made. I just said, let me...
No, above. The 2 lines above.
These 2?
Yeah, yes.
Okay.
It's these 2 equations are linked, or?
Yeah. So this is the... so let me go back to my constraints I had.
But what did you do
Yeah,
to
here they
obtain
are.
the second?
Yeah,
Okay.
so it's just here, this is what I had. So what I don't consume, I get money from, and then the money I have for tomorrow. Then the only thing I've done is change MT and add times 1 plus R. So, and that's the second constraint. All right. And that's what I get here. So that's the second constraint here. So it's just saying empty, I didn't keep it in my house under my bed, in my mattress. I gave it to some person who agreed to give me some interest. Is that clear?
Yes.
Okay.
Thank you.
So, but then we had a very good question: is why would I need to, or where would I find somebody to lend me money or to accept to give me money back? So why is that? Why is this a relevant question?
Well, because otherwise Rn is equal to 0.
Yes, but why would Rn, so just in the model, why would I not be able to find somebody or to give me some interest on my money? Or why would my agents not do that?
Because they cannot pay it back when they retired, because they don't work.
Yes, exactly. So that's so 2 reasons. One is, first of all, I cannot, or why I wouldn't do it with people who are born at the same moment as me. Well, because they're the same, they produce the same, and they consume the same. So there's really no need to trade anything or to have some intertemporal market between us. What would be interesting is to have some intertemporal market with other generations that don't consume and produce at the same time as I do. But as exactly was said, so it doesn't work, because I will have to tell some old person right now, oh, I lend you money, and then some new person in the future give me back this money with interest. So obviously that cannot happen. So this kind of financial market wouldn't be possible. So RNT would essentially be 0. So the best thing I can do is receive 0 interest by keeping money under my mattress. But still, so RR still exists. So that's just a way for me to define what RR is. So RR is going to be, I'm going to say it's R money. So it's sort of the interest rate on money that comes from the fact that money changes value. So it's the negative of the inflation rate. So, oh, sorry. Yeah. So we had that. Yeah. R was Rn minus pi t. So of course, if Rn is 0, so I just get that RT money is minus pi t. So it's essentially like saying, oh, to keep money, I have to pay to lose some value to it, which is because the stuff that's in my mattress maybe is going to lose money over time because of inflation. So so that's why it's an interest, negative interest rate. So this is why exactly what we said. So there's no, it's impossible to have a financial market between generation, and it's useless to have them within generation. Yeah. Okay. Okay, so now let's finish by testing your knowledge of or your memories of microeconomics. So here is the quiz. So you can, I've realized that you can kind of use the graph, this graph, but not entirely. You also have to use your knowledge of this model of intertemporal constraint. So if you don't do perfect, don't worry. You know, it's microeconomics, but it's good to refresh these notions, to put you back in it, and then we can correct it together. Actually, I think this first question is almost the most difficult. Yeah, I would say this one is the most difficult. Usually it's best to finish with the most difficult, but yeah, it's here. So in the interior solution, so in this solution, interior solution, what I'm saying all the time is that all values have positive, all variables have positive values. So here, consumption has positive value in the present and the future. So in this solution, so what happens to consumption in time t if inflation goes up? So inflation in time t, of course. In the interior solution, the same thing. What happens to consumption ct t plus 1? So consumption in the next period if inflation goes up. In the corner solution, what happens? So the corner solution that we care about, so the ones where we consume all today, what happens if at consumption today if inflation goes up? In the corner solution, what happens if inflation goes up for consumption tomorrow? And then what would be the real interest rate on money? So our money, so this thing here. If inflation rate goes to infinity, and with inflation rate that goes to infinity, what type of solution would we most likely to have? So are we more likely to have an interior solution or to have a corner solution? And you can answer these on the website on quiz 5.
Do we assume the concavity of the utility function?
Did somebody talk or?
Yeah. Do we assume the concavity of the utility functions?
Convexity, yes.
No.
Or yeah, sorry, yeah.
And then the
Convexity of
concavity.
the so yeah. So you yeah, you get so yeah with the assumptions that we give you, yes, you can assume it, yes. This is a utility function.
Okay.
Yeah, I'm not tricking you in any ways. Yeah, so the yeah, the indifference curves will look like this. They're going to be convex for the towards the origin. Okay, so let's see if some of you have started answering. Yeah. Oh, I'm happy. I see some good answers. Yeah, micro is a tricky topic. I really like it, but yeah, we have to. It's a tiny mathematical model, and they can be tricky sometimes. Yes, I think you're doing much better than last year. I'm happy. Oh, it's almost finished. Okay, so I think, all right, so answer that and we're going to correct it next time. Oh, I haven't, sorry, I hadn't looked at the clock. All right, so, well, keep sending the questions and yeah, we're going to correct that next time. But I'm very happy to see that most of you seem to be doing quite well. I'm going to still stay here just in case you have some questions about the quiz.
Could you at least explain question 4?
Yeah, so.
Can you explain question 3, please?
Yeah, okay, sure. So in the corner solution, so I mean here, what happens if inflation goes up? So inflation is pi t. So if in that situation inflation goes up, what's going to happen for consumption?
It's a little w. I don't know how you called it. It stays the same.
Oh well, it's possible, but so maybe the others you can get inspiration from this answer.
In the axis of CT, W stays the same because the axis of CT doesn't depend on the inflation rate, no?
Yeah, exactly. So here, omega is just how much work you can produce, and it has nothing to do with prices.
Okay. And for the ones?
For the one?
Yes.
The question 1?
Yes.
Oh yeah.
Why the interior change?
Okay, so what's the answer?
No, I have seen the answer.
Okay.
I don't understand why.
Oh, so you have the answers or not?
Yes, in the handouts.
Oh. Okay. Well, so I wanted to say that, so it's tricky because here is a quote, something I read in a New York Times article once, written by Tyler Cowen. If you know him, he's a super smart economist, very knowledgeable, very wise. And he wrote this. So, because back then they had, so it was, I think, I'm not too sure exactly when he wrote it, if it was just after the crisis or before. But basically, so they were thinking about how should we start again consumption so that the economy would restart. And then he says this following: so if the Fed promises to keep increasing the money supply until prices rise by say 3% a year, so basically if the Fed promises to create inflation, so to have inflation, then people should eventually start spending. Otherwise, they should they just held the money. It would be worth 3% less each year. So it looks like he's saying that if inflation goes up, then CT should go up because people are going to know, oh, my money is going to be less in the future, so I should spend more. But then why is it ambiguous? Does somebody have an answer?
I mean, we can save with something else than money. In reality, I mean. For instance, real estate is kind of correlated to inflation.
Okay. Yeah. Okay. That's a good point. Yes, but in a way, so if you save in some other vehicle, but then this vehicle is denominated in the same national currency, like in the US dollar, then if you wait 3 years later, then you get your return, but it's still worth less because prices have gone up. No? What you would have to do is to change your money for some other currency of some other country, then wait 3 years and then change it back. So that way that will work.
Okay.
So, but okay. So I'm just going to finish with this because we're over time here. So why is it ambiguous? Well, actually, don't think that's even something that they show in micro. I think that they show what happens to consumption if we change interest rates, but not if we change inflation. But what happens if you change inflation is that two things happen. First of all, there's a substitution effect. That's what he has in mind is, okay, prices are higher tomorrow compared to today, so let's consume more today compared to tomorrow. So consumption today should go up. But there's a second effect. Does somebody remember the name? The other effect than the substitution effect?
The income effect?
Yes, income effect. And how is that effect going there?
Negatively.
Yes, because prices go up, then it means that I anticipate that tomorrow I'm going to be able to consume less. So actually, I want to think, oh, maybe I should save a bit more to make up for that. So you see that I want to save less because it's not worth to consume tomorrow, but also I want to save more because I know that I'm going to need money to consume more tomorrow. So the net impact is actually ambiguous. Whereas in number two, it's not ambiguous because the two effects go in the same way. So I'm poorer, so I can consume less tomorrow. And also prices are more expensive tomorrow. So for the two reasons, CT, T plus one is going to go down. But CTT is going to, it's ambiguous. And what you can see it on the graph, basically if this blue curve or line, straight line, becomes like this, for instance. So how is my utility going to touch this blue line? I can try to draw it.
The utility will be flatter?
Yes. Oops. So the purchase constraint would look like this, for instance. But then I could have a utility that looks like this. Something like this that touches here. Or I could have some utility that looks like this that touches there. So you see that the two, oops, no, here it's not working well, but I could look like this. And in that case, CT would have gone down or CT would have gone up. So it depends on the strength of the income effect. But yeah, that's why I'm saying it's when I wrote the quiz, I thought, oh yeah, I'm going to ask about consumption today, tomorrow, but micro is tricky when you have to, even good economists like Tyler Cohen didn't think about this income effect when he wrote his article. So, all right, so let's say it's finished today here and continue to answer next time.
Thank you.
Thanks a lot.
Thank you. Bye.
Bye.
Thank you. Bye.